Hello guys, and welcome to my YouTube channel. I know it's been a while, but I'm back now. So today we are going to look at quantity surveying info. We are going to do a roof calculation using this structure here. Okay, on a roof calculation, guys, we have items to be measured, as you can see, and we have specifications. So on items to be measured, we have on trusses, we have on roof covering and masonry. And then specifications, they say all timber for the trusses are 38 by 114 millimeter pre-treated South African pine trusses are spaced at 700 millimeters. And then we have 38 by 114 millimeter wall plate. We have 75 by 75 millimeter wrought eaves purlins, and we have 300 millimeter overhang at eaves. We have 100 millimeter overhang at wedges. We have galvanized sheet iron roof cover, galvanized sheet iron ridge piece. Pitch for the roof truss is 30 degrees. Brickwork 220 millimeter thick, and then we have 50 by 75 millimeter SSAP purlins. So number one, they asked us to draw the roof truss to a scale of 1:10, and then we have to take off all roof trusses, roof covering, and masonry brickwork. So for the drawing, there's no need for us to draw that. We already have the drawing on that structure I showed you. So let's get to work. Okay guys, so this is our dimension paper where the calculations will be done, right? So please note that on your exam you will get a dimension paper, but it will be blank. These drawings of a checklist and the dimensions will not be there, so you just have to know them. So now we are going to start by calculating the number of roof trusses, right? So to calculate the number of roof trusses, we are going to take the length of the floor plan and minus 220. This is the thickness of the okay, let me say this is the size of the brick work. I don't know if I'm making sense, or let me just say this is the thickness of the floor plan. Yeah, I think it makes sense that way. So you're going to take this length of the floor plan minus 2 times 220, the thickness of the floor plan. We multiply it by 2 because it is on this side and on this side, so it appears on both sides. We're going to take this length minus 2 times 220, right? So let's do that. Okay guys, as you can see here, I don't have much space to do the calculations, but I'll try to do them. So you are going to say collections, and then you're going to take the length of the floor plan, which is 6,000, minus the thickness, minus 2 times the thickness of the floor plan, and then we have 5,560. Now you're going to take this 5,560, divide it by 700. I'll show you where I got that 700. So the 700 is this one. This is the number of spaces between the roof trusses. As you can see here, they say trusses are spaced at 700. So you're going to take 5,560 divided by this 700. So you're going to divide by 700, and then okay, 5,560 divided by 700, we have 7,94, right? So this is the number of roof trusses, but we cannot have it like this, so we need to add 1, right? You take this 7,94, you add 1, say 7,94 plus 1, and then you have 8, right? Okay, sorry, that was my mistake. You are going to say you add 1 here, right? Okay, you add 1 here, and then you have 8, right? So you're going to say 8 plus 1, and then you have 9. So this is the total number of your roof trusses. Okay, so you have 7.94, you add 1, you have 8, you add another 1 again, and then you have 9. This is the total number of your roof trusses. So guys, you know that on the roof trusses we have eking post, rafter, tie beam, queen post, truss, etc, right? So now we are going to look at the king post and the rafter, because in our structure we have only king post and the rafter. We don't have a tie beam and what do you call this, a tie beam and a queen post in a struct, you know. So sorry, you are going to say, okay, we have the following 38 by 114 millimeter structural timber not exceeding 2.4 meter in length, right? So you're going to say the height, you're going to take the height of the king post, which is the height of the king post is 950. So you're going to take 950, you multiply it by the number of the roof trusses. So on our dimension column, we're going to take the height of the king post, which is 950. So you're going to take 950 divided by 1000. 950 divided by 1000, it's going to give you 0.95, and you multiply it by the number of roof trusses, which is 9, right? So we are done with the king post. Now coming to rafter, you're going to take the length of the rafter, right? You're going to take the length of the rafter, multiply it by the number of the roof trusses, multiply it by 2 sides. So you're going to take this length of the rafter, right, and multiply it by the number of the roof trusses, which is 9, and multiply it again by 2 sides, which is this side and this side, right? So as you can see, the length of the rafter is 2,300. You're going to take this 2,300 divided by 1000. So you have the length is 2,300, right? So 2,300 divided by 1000 is 2,30. We multiply it by the number of the roof trusses, multiply it again by 2 sides, right? And then we are done with the rafter. Now we are going to calculate. They say ditto, meaning the same as this one, right? So ditto is excavated or excavation 2.4 and not exceeding 3.9 meter in length. So we're going to calculate the tie beam. Remember, the tie beam, the king post, and the rafter, we use the same material, right? So on the tie beam, you're going to say the height of the floor plan minus 2 times the thickness of the floor plane, right? You get that answer, and then you take it to the dimension column. Okay guys, so I made a mistake, right? So on the tie beam, you know that the tie beam it's that on the half a wall of a 220, right? So you're going to take the height of the floor plane, which is 3000, minus 2 times 110, right? 110 is the half of a one brick wall. A one brick wall is 220, right? So 220 divided by 2, it's 110. So you take that 110, multiply it by two sides. So actually I was correct. You're going to take the oh no, I was wrong. Okay, you're going to take the height of the floor plan minus 2 times 110, and you know that 2 times 110 is 220. So you're going to take the height of the floor plan minus 220. Okay, the height of the floor plan is 3000, right? Minus 2 times 110, which is 220, and then you have 2700. You have 2700. So you're going to take this 2700 divided by 1000, and you have 2.70. You multiply it by the number of roof trusses, which is 9, and just like that we are done with the tie beam, right? So now we're going to the wall plate. On the wall plate we have 38 by 114 millimeter wall plate. So on the wall plate, guys, we are going to add okay, sorry, we are not going to add. On the wall plate we are going to, okay guys, on the wall plate we are going to say 6000 minus 6000 is the length of the floor plan, so it's 6000 minus 2 times 220, which is 5560. So it is this one. Actually we have already calculated it, so we're just going to note it on the dimension column. So it's 5560 divided by 1000. We have 5560, right? And then we are going to multiply it by two sides. I'm going to multiply it by two sides. I hope that makes sense, right? So you take the length of the floor plan minus 2 times the thickness of the wall of the floor plan, and then you get an answer, which is this one. Take this answer divided by 1000. You note it on the dimension column. You multiply it by two sides, right? Now we are going to splay cards to rafter ends and of trusses and a hoop iron roof ties, right? So on a splay cards we need 1, splay cards and hoop iron we need both we need 1, right? So we're just going to note 1. You multiply this one by 9, the number of the roof trusses, multiply it again by 2 sides, right? And we are done calculating. I must play cards and hoop iron. Now sizaku roof covering. Now we are calculating a roof covering, right? So on a roof covering, we have a checklist of purlins, covering, fascia board, and batch board. Now we are going to look at this as the first one, at purlins. So 50 by 75 millimeter. This is the length and this is the height. So we have 50 by 75 millimeter as AP purlins. So to calculate this, we're going to take the length of the floor plan, right? Length of the floor plan. You're going to take the length of the floor plan plus 2 times 100. Now 100 is the 100 millimeter is the overhang at wedges. 100 millimeter is the overhang at wedges. So we are going to take the length of the floor plan plus 2 times 100. So 6,000 plus 2 times 100. We have 6,200. Have 6,200. You take the 6,200, you divide it by 1,000. It gives you 6.20, and you multiply it by 2 sides. Multiply by 2 sides, and then you are done with purlins. Now we are calculating 75 by 75 millimeter rod SAP Eves purlins. We're just going to say again 6,000 plus 2 times 100, and then you have 6,200. It is the same as this one actually. So it's 6,200. Multiply it by 2 sides, right? So now we are at a roof covering. On the roof covering, you are going to say again length of floor plan plus 2 times 100. And then you're going to get an answer. So you're going to say 6,000 plus 2 times 100, which is 6,200. You multiply it by the length of the rafter, which is 2,300. Then you multiply by 2 sides, and that's that. Now we are going to calculate the same thing. Ditto means the same thing. So a rich piece. On the rich piece, we are going to say 6,000 plus 2 times 100. It's 6,200. So we have 6,200, and then we are done with the rich piece. And now fascia board. On fascia board, the same thing. Length of floor plan plus 2 times 100. You have 6,200. this time you're going to times by 2 sides. You're going to multiply by 2 sides. Now on the batch board, the same thing, but now it's a batch board. So 6,200. By now I'm sure you know, where did I get this 6,200? You multiply it by 2, multiply it by 2 again, right? So this 2 is so this 2 is the number of the batch boards that we're going to need. Is all the calculations that needed to be measured or needed to be done. Please like and subscribe, and thank you for watching this video. See you next time. Bye.